discussing so the discussion was about the calculation of the RMS value of the following currents, right? So you can see on the screen we have two questions, and there is a question that current is given as a function of time, that's a plus b sine of omega t, right? And the second question is given as a sine omega t plus b cos omega t, right? So we have to calculate the RMS value, right? We have to calculate the RMS value. What we'll do here is that we'll first square the current, right? Then we'll calculate the mean of that square, and finally we'll just put the root on that mean square value. We'll get the RMS value, right? So it's a very simple task to do, right? Very straightforward. So what we have done is that we have squared it on both sides, right? We'll square it on both sides. Upon squaring on both sides, we'll expand this square term, right? It will be a square plus b square sine square omega t, right? Plus 2ab sine of omega t, right? So this will be the expansion, right? Now this will be the current square term, right? What we'll do here is that we'll just take the average of this on both sides. It will be a square plus b square sine square omega t, right? Plus average of 2ab sine of omega t. Now we know that average of sine of theta is 0 for a complete cycle, right? So average of this term will be 0. Right, and the average of the sine square theta for the complete cycle is 1 by 2, right? It's 1 by 2. So we can write here average of a square will be a square, and the average of sine square omega t will be 1 by 2. That is p square by 2, right? So this is our mean square value, right? This is nothing, this is mean square value. So root mean square will be nothing. We'll just take the root on this mean square to calculate the RMS value. So this will be the RMS value here, right? Under root of a square plus b square upon 2. So this is the RMS value of this current, right? Similarly, for the second part here, right? For the second part here, I will square the current on both sides. Once squaring the current on both sides, that will be a sine omega t plus b cos omega t, right? Whole square, right? Whole square. I will expand it. It will be a square sine square omega t plus b square cos square omega t plus twice AB sine omega t cos omega t, right? Now, this is the square value, right? This is the square value of the current. What we'll do is that we'll just calculate the mean of this square current here, right? So we'll be taking the average of mean of each and every term here, right? It will be a square sine square omega t plus average of p square cos square omega t, right? And average of 2ab. Now we can also write it as 2 sine omega t cos omega t. We can write it as AB sine of 2 omega t, right? Now, average of sine square omega t, it will be half. We'll be left with a square by 2, and we'll have b square by 2. And the average value of this sine of theta term will be equal to 0, right? So it will be equal to 0. So we'll be having a square plus b square upon 2, right? So this is the mean square value of the current, right? So the RMS value of the current will be, RMS value will be nothing. IRMS will be, we'll just take the root on both sides. So this will be the RMS value, a square plus b square upon 2. So this will be the RMS value of the current, right? So this is how we calculate the RMS value of different given currents or voltage, right? Now let's move on to the question, next question. The question is that if V1 is equal to V0 sine of omega t, V2 is given as V0 sine of omega t plus pi by 3, then resultant of the two voltages is, right? So what we can do is that we can just plot these two or represent these two voltages in the form of phasors, right? In a Cartesian plane, right? Phasors that we call as phasor diagram, right? So you can see here V naught sine of omega t at time t equal to 0, the initial phase is equal to 0. So what will how actually we draw the phasors is like this. Let's suppose this is the Cartesian system, right? Now we can represent this. V1 in the form of a vector that we call as a phasor here, right? Now at time t equal to 0, you can see here the value of the voltage is 0, right? It's equal to 0, right? It means that there is no initial phase for V1, right? Or we can represent this with this vector, right? And the initial phase for the V2 here is pi by 3. It means that V2 will be leading V1, right? When angle of pi by 3, right? So it means the angle between the two phases V1 and V2 here will be equal to pi by 3, right? Pi by 3. So the resultant of the two voltage, this will be the resultant of the two voltage, right? This will be the resultant of the two voltage. Let me represent it by VR, right? VR. So VR will be the resultant of the two voltage, right? So the amplitude of V1 will be nothing. Amplitude of V1 will be nothing. It will be the component along y-axis, and the amplitude of V2 will be also the component along. It will be a component along at time t equal to 0. So the maximum value of V2 here is V naught, right? It means that the maximum value of V2 here, it is actually V naught, right? So V naught will be the amplitude of this V2 voltage, and V naught will be the amplitude of V1 voltage, right? So if we calculate the amplitude of the resultant voltage, it will be nothing. It will be the same as we add the two vectors. In the same way, we will be adding the two phasors as that of vectors to calculate the resultant or the resultant amplitude of the two given voltage, right? So it will be VR, it will be V1 square plus V2 square plus twice V1 V2 cos of phi, where phi is nothing, is the phase difference between the two given voltage, right? So V1 square, it will be V naught square plus V naught square plus twice V naught square. So the phase difference between them is pi by 3. Cos of pi by 3 will be 1 by 2. We'll divide it by 1 by 2, right? So it will be 3 V naught square, right? So it has to be 3 V naught square, right? So it is V naught square, right? V naught square plus twice V1 V2 cos of phi. So cos of pi by 3 will be cos 60, that's 1 by 2, yes. So it will be 3 root 3 V naught square, right? Root 3 V naught, right? This will be the resultant amplitude of the resultant voltage, right? For the two given voltage, right? Let's move on to the next question. In a given circuit, applied voltage is 50 root 2 sine of omega t and ammeter reading is 2 ampere. Then calculate the value of L. Whenever we say that the ammeter reading is 2 amperes, actually the reading we're talking about is the RMS value of the current, right? Because we know that whenever a voltage is a AC voltage, the current is also AC current, right? The current continuously changes with time, right? So the current is not has not the fixed value at a given time, right? The current continuously changes, right? But when we talk about the measurement of the some constant value, when we talk about that ammeter has measured this constant value or voltmeter has measured this much of voltage, right? Then at that time we're actually talking about the RMS values of the voltage and RMS values of the current. In the same manner here, it's given that the ammeter reading is 2 ampere, right? When we know that the current is a variable current, when it is talking about the constant current 2 ampere, actually it's talking about, the question is talking about the IRMS value of the current, right? So 2 ampere is here is nothing, it's the RMS value of the current, right? It's the RMS value of the current, right? So RMS value of the current is given as 2 ampere, right? We have to calculate the value of L, right? We have to calculate the value of L. We know that VRMS will be nothing, VRMS will be nothing, it will be equal to uh, let's suppose if we have this inductor right in the circuit, right? This is the inductor, and there is some AC supply to this inductor, right? There is some AC supply to this inductor, right? And let's suppose the self-inductance of this inductor is L, and there is some current I flowing through this inductor, right? And we know that VRMS will be equal to IRMS multiplied by Z, right? Z will be the impedance or total resistance, we can say, right? Now here it's a pure inductive circuit here, right? So it will be IRMS multiplied with the reactance offered by this inductor. That will be XL, right? That will be XL. Now XL is nothing. It's actually equal to omega L, right? It's actually equal to omega L. And VRMS, we know that VRMS is nothing. That's actually equal to the peak value of the voltage upon the root 2. Now you can see here the peak value of the voltage is 50 root 2, right? 50 root 2 upon root 2. This will be the peak voltage, right? Or 50 will be equal to the RMS value of this voltage, right? So if RMS value of the voltage is equal to 50, and IRMS is given as 2 amperes, right? And XL is omega L, right? It will be omega L, or we can say that the value of L from here will be nothing. It will be 25 upon omega, right? 25 upon omega, right? Now the value of omega you can calculate from this equation, right? You can see if we compare this equation with V naught sine of omega t, right? The value of V naught comes out to be 50 root 2, and the value of the omega comes out to be 105. So we can substitute the value of omega here equal to 100 pi, right? 100 pi. So, or we can say 1 upon 4 pi Henry will be the value of L. 1 upon 4 pi Henry will be the value of L for this given question, right? Now let's move on to the next question. Calculate the impedance of the circuit shown in the figure, right? So we know that in case of capacitor and resistance, right? We know that in case of capacitor, the current leads the voltage by 2, right? By 2, or we can say we can represent this is the right. This is the voltage, or we can say this is the voltage through the capacitor, and this is the current through the resistor, and this is the voltage through the resistor. That's VR. So the resultant of these two voltages will be here. It will be nothing. It will be under root of VC square plus VR square. So this will be the resultant voltage across the two, across the resultant voltage actually supplied by this input AC, right? So V resultant we can write it as V, that will be under root of VC square plus VR square, right? VR square, right? Now we can write, let's suppose the total impedance offered by this, if the current I is flowing through this circuit and the total impedance offered by this circuit is Z, we can replace it with I into Z, right? And the current flowing through the two elements is same because they're in series, right? So you can write it as I square VC, it will be XC square, right? And similarly it will be I square R square, right? So from here you can take I as common, right? It will be under root of XC square plus R square, right? It will be I multiplied by Z. So from here Z will be the total impedance, that will be nothing, it will be equal to XC square plus R square, right? So value of XC here is given as 40, it will be 40 square, and the value of R is given as 30, it will be 30 square, right? So it will be actually equal to 50, right? The total impedance offered by this circuit is actually 50 ohms, right? So 50 ohm will be the total impedance offered by this circuit, right? Let's move on to the next question, right? The question is that find out the required inductance to put in series of bulb of 10 watt 60 volt to run it safely across an alternating supply of 100 volt, right? The given frequency of given frequency of the input AC is given as 60 hertz, right? Now you can see here, yeah, we have to find the required inductance, right? We have to find the value of this L, right? Value of this L. We know that if there is some current flowing through the circuit, right? There is some current flowing through the circuit, right? Same amount of the current will be flowing through the resistor as well as inductor, right? So we'll first of all calculate this current I, right? The total power consumption by this resistor is given as 10 watt, right? We know power is nothing. We can write it as V multiplied by I here, right? V multiplied by I, or we can say it's VRMS, IRMS for the pure resistor circuit, right? For the pure resistor, right? Now it's given that RMS values is given as this is the, we can write here it as VRMS multiplied by IRMS, right? Now you can see here the VRMS value is given as 60 volt, right? Through this it is 60, right? It's 60, or the current through it, let's suppose I is the current, right? And the power consumption is 10 volts, so 10 upon 60 it will be the current I, that will be equal to 1 upon 6 amperes, right? So 1 upon 6 amperes is the current flowing through this circuit, right? 1 upon 6 amperes, right? If 1 upon 6 amperes is the current flowing through the circuit, if 100 volt is the total root RMS value and 60 volt is across this, then it has to be 40 volts across this, right? 40 volts across this, right? Now 40 volt is the voltage, we can say the VL value here is nothing, it's equal to 40 volts, right? We can write this VL as I multiplied by XL, right? I multiplied by XL, right? And the current here is flowing, that's 1 upon 6 amperes, or XL upon 6 will be equal to 40, right? So the value of XL will be here, that will be equal to, uh, will be equal to 240, right? 240. Now we can write XL as omega L, right? Omega multiplied by L. So 2 into 40, right? The value of L will be nothing. It will be 240 upon omega, right? Omega we can write as 2 pi times 60, right? And this will get cancelled. It will be 4 upon 2 pi, right? Or we can write it as 2 upon pi Henry, right? So this much will be the actually inductance of this given inductor in the series with the resistor for the given circuit, right? So this is how we can calculate or apply the different equations to the AC circuits, right? Now let's discuss this last question with respect to the AC currents, right? Across two inductors, same alternating source is connected. For this Z versus omega graph is given, find out L1 upon L2, right? Now you can see here we have been given the graph between Z and omega, and we have to find the ratio between the two inductances of the two different inductors, right? L1 and L2, right? Now you can see here, we can write here the equation for this straight line will be nothing. Z will be equal to let's suppose m is the slope and omega, right? And the intercept here is 0, right? Because it's passing through the origin. Or we can write this slope is equal to, it will be tan of phi, right? Tan of phi, it will be equal to Z upon omega, right? Z upon omega. Since we're talking about a pure inductive circuit only, right? So we can replace Z with omega L divided by omega. So omega and omega will get cancelled. We'll be left with the inductance of the inductor only, right? So tan of phi will give us only the inductor of the inductance. Or we can say tan of phi 1 upon tan of phi 2 will be nothing. It has to be equal to L1 upon L2, right? L1 upon L2. Now you can see here for the first graph, the angle it makes with the x-axis is 60 degree, and for the second graph, it makes a 30 degree angle, right? 30 degree angle. So L1 and L1 upon L2 will be nothing. Tan of 60 upon tan of 30, right? Tan of 60 upon tan of 30 degree, right? Now from here, L1 upon L2 will be tan 60 is root 3 upon 1 upon root 3, right? So it will be nothing. It will be 3 ratio 1, right? 3 ratio 1. So L1 upon L2 will be nothing. It will be 3 ratio 1. So that's it with respect to the today's session, right? We'll be discussing further more questions with respect to the AC alternating current, right? In the next upcoming lecture, right? So till then, take care and goodbye.